So, in today we will be talking about vulnerability hunting and responsible disclosure. It's very, very funky thing. Everybody is talking about vulnerability hunting, bug hunting, or whatever you call it. But that's something that has been going around and around for the past couple of years. So I'll be just focusing on the Android bug hunting because this is something where I actually did a responsible disclosure and we will be talking about how the applications are developed for the Android applications, the background, the processes that are involved in the development of the Android application. And when the Android application development started back in, I guess, 10 years ago, I believe, or 12 years ago, I believe, they were just built on the native Java-based, code, or you can say the platform. But now it has totally changed towards introducing React Native and technologies where you can utilize their WebView audio to build the Android application. And again, it's not just about the common vulnerabilities, but if they are chained along, they can create a catastrophic effect. So at the end of this, we'll get back to this secret soon. Just hang in there. So a little bit introduction. I do the security stuff here in Pakistan in a banking sector. In my free time, I just do the security research thing. Like I just like to, tear apart the network adapters or network routers, or let's say anything that's very fascinating for me. At the technology and let's say the software and Android applications, or you can say web applications, APIs specifically, and together IoT and ARM are the next big thing in the industry. So hopefully I'll be able to learn ARM by the end of this year, as this is something I have targeted for this year, and looking forward to learn stuff around IoT and ARM. So let's just kick in. How do actually Android applications starts, like how their development starts? So basically, we have this two kind of types where in one of the type we usually develop applications through native libraries, let's say the Java libraries or the Android native libraries. Now they have turned into the Kotlin level. So by that, you can, develop the Android applications more efficiently. And then there is another one called the cross-platform, where we utilize some technologies which are, Cordova is kind of a new thing, and React Native as well. So, but that we actually, makes bit easier for us to develop an application, a single application, and then you build the same application on the Android platform as well as on the iOS. So that somehow, squeeze the time that takes for the development and makes it more efficient for the guys, for the IT guys, let's say the Android guys who are developing, more efficient. So how the development is done, where the Java Kotlin then is, compiled, and further it is, uh, excuse me, what happened? So actually, the native application that has been developed in Java, that is then assembled, or you can say compiled, and the compiled form is then, the text format where the bytecode is actually residing. And when we are trying to, decompile the application for the reverse engineering purposes, we actually decompile the text code, the text byte code, which turns into the, the Somali code. Somali is actually the assembly code, and then we decompile that Somali code into the Java native, code, or whatever you call it. And when we are using the cross-platform technology, we get a lot of JavaScript files. Let's say it specifically works like a web application, but it utilizes the WebView API of the Android. So whenever you open up an application that is built on cross-platform, it requests for a web application page and then loads the stuff over there. So there are some common vulnerabilities that are discussed by the OWASP, and they are pretty out there in their OWASP top 10 vulnerabilities. But I'll just run through this and I'll try to explain as much as I can. The insecure data storage, let's say the application is utilizing the internal database, let's say SQLite database, or the web database, web cache database that has been utilized by the Android application. So whenever you are trying to, store the credentials or stuff like keys or the hashes within the application storage module, most of the applications get compromised through that. And that includes the insecure communication. Let's say if you have stored these credentials in your local database, the SQLite database, you might get that into the communication, like you're trying to intercept the communication from your Android application to the server. So you get that plain text, and sometimes there's no integrity check at server and at the client end. So that's how you can bypass it. Are insufficient HSTS policies. Let's say we usually talk about SSL pinning. So one of them is actually covering the HSTS policies, etc. And then we have this insecure authentication, where we usually try to bypass the pages through, you can say, different tabs or the pages that you are trying to browse within the application. So, for example, there's a banking application and you're trying to log into the application, but in an attacker perspective, you can bypass them by just calling the intents or the class name through different sources, or you can say from the console, and you'd be able to get the view of that intent as well. And then again, there comes the point where it says insecure authorization. We have usually experienced this in the time when we are trying to log into the application, and it tries to save the cookies within the web browser, and then we find that there's a value which says admin is equal to 0 or admin is equal to 1. So once we change that, we get the admin rights, or we get the super administrative rights on the application, and then we can do as much as we want. Again, there is something that has been not discussed, which is very important at this point, which says that the application obfuscation and binary protection, because that is the first level of defense that needs to be built while developing the applications. Say, for example, I am developing a banking application, and I'm just leaving there um, uh, my code in the my code in the plain text, and someone tries to decompile the application and find out the source code. I can uh, you know rebuild that code and attach any kind of malware or whatever stuff you can like, and then send it to people who won't even try to give it a try and just install it. So in my all of this experience, while I was hunting for vulnerabilities in Android application, I did disclose responsibly to few of the organization. But let's just get back to this responsibly disclosing it thing. In our example, let's say if somebody is trying to get into your house, or if somebody is trying to steal your car, what you're going to do is you're going to report it to the police, local authorities, just to make sure the guy is caught. So in a similar case, what the security researcher do is find out the vulnerabilities or find out the loopholes, and then report to the competent authorities, or the authorities that deal with this, all of the IT stuff, or the application owner, or the whatever you call it, they just to make sure they patch it. And most of the cases we have seen that in a good faith, the researchers try to approach the relevant authorities. However, this has been always taken as something against them, and some people have taken it as hurting their ego. So in all of these cases where things have turned against them, have made the security researcher and the security community bit very reluctant in disclosing such vulnerabilities. One of the cases, I mean, and there's a guy on the Twitter who did a responsible disclosure to the Argentinian government, and he was later arrested for something he didn't do that, and he had to suffer a lot of pain for the thing he didn't do that. So when we are talking about disclosure, there are actually two type of disclosures, and full disclosures and the responsible disclosures. So in the full disclosures, we actually uh, the security researchers, we have actually seen them disclosing each and everything over the internet without even waiting for the vendor or for the person to, patch the vulnerability or release a vulnerability against the release the patch against the vulnerability. Sorry. So in that case, they justify this as something to be known to the to the larger audience around the globe, just to make sure they can secure their stuff, or they can keep their stuff secure, and just and I mean, don't fall for the trap. And in the response for disclosure, the hackers or the security researchers actually contact the organizations and try to, explain them each and every step which was involved in identifying the vulnerability, and then through a coordinated disclosure, they disclose the vulnerability, and after patching that, they disclose the vulnerability to the public. So my experience with the responsible disclosure was pretty good, and at a time it was pretty worse because the disclosure involved a government entity. They were working with the local authorities here in the country where I reside. So that application actually had a lot of customer information. Not the application itself had the data for the customers, for the people, or for the people are living in the country, but it had the API to call any national identification number. You can say whatever number you can, just to make a query and get the details of their father, their mother, and their grandparents eventually. So what actually was happening at the back was they were using a API and hard coding the credentials within the API URL. So whenever you try to, hit the, query for something from that API, from whatever network it was using, these, API keys were exposed, and the application was actually communicating on plain text. Let's say in HTTP, they were using HTTP. So anybody, if he or she or anyone, if they are within the facility where the application is being utilized, they can, capture the network request and make the same request over the internet by forging it. And in the other screenshot, you can see that a lot of the residents critical information is displayed. So that was pretty huge, and we tried to, disclose that to the government entity who was dealing with this kind of data, and they tried to silence us by saying that they're gonna, sue us in the court, or you can say they're gonna uh, launch an investigation in hacking into in their servers. So that was a pretty bad experience, and I'll share what actually happened after that. In another corporate organization, there was this IDOR-based vulnerability in the application, and it had around 16,000 users, 16,000 customers in their database, which included their names, their email addresses, their device IDs, Android device ID or iOS device ID, their phone numbers, as well as their home address. So that was a coffee shop, you can say, or a place where they served desserts to the public, and they were storing some critical information in the local database. And what actually I did was, it was again a IDOR based vulnerability. So I created a script, and I try to extract all of the information from the script. But again, I chose to not to make it a very uh, like getting in between the silver lines and disclosing it to the organization more responsibly. But again, they wanted me to explore and show them all of the details, like convincing them that their database can actually be compromised if they don't patch their vulnerability. So I ran through all of the records and showed them all of the records, and I told them that these are the records, they are available, even though I disclosed them my IP address and the details I was using. So that was something a very good experience. And the company actually appreciated for the efforts. I didn't get any benefits, or you can say vouchers for something like that, but they were pretty response their response was pretty nice in patching the vulnerability. So again, accused of hacking, the local news media outlets tried to catch this as something, hacking or something hacked, and then they try to portray the security researchers as the bad person. But at the end of the day, the head of the government entity uh, took over the decision and said that they are going to take legal actions for whoever was responsible in propagating false and malicious content. But again, this wasn't a malicious content, and every proof was out there. But then comes the good part, where the companies, like I discussed earlier, really appreciate the security researchers. For example, this one, I reached out to them and I explained them briefly about the security vulnerabilities on their forum. And through that forum, they created a support ticket. They actually didn't had any responsible disclosure program or a security based, a team that could lead their responsible disclosure, or you can say their security activities within the organization. So they created a support ticket for me, and they asked me to post all of the details. And then out of sudden, they decided to reward me for this. And then I got in touch with their head of platform engineering, who really appreciated my efforts and invited me to a bug bounty program. So before that, I wasn't doing any bug bounty program. I wasn't actually getting involved with the bug bounty platforms, but this was the first time I was, uh, looking forward to um, hunt for more vulnerabilities on the bug bounty platform. So yeah, then this was the second company, the dessert company, the company that was offering coffee or tea or whatever you name it. Their CTO had actually invited me in person, and they wanted to discuss the gaps and the I had identified, and that was a pretty good meeting. And they actually fixed their application. So now with all of this, everybody would be thinking, how can they do that? The basic and the most important thing is be responsible, and only play with the data you own. Let's say if you are doing stuff on the Android application or a mobile, any kind of mobile application or a web application, you must create two accounts and try to, if you are looking for a vulnerability in horizontal privilege escalation or vertical privilege escalation, just create two accounts and try to play with that rather, I mean, uh, getting into the other accounts that are that you are not intended to get into. And just don't shout out on the social media and throw it into the teams, because I've seen security teams with the head count of only two guys and looking after the organization that works as a fintech. So we should be very careful in saying out things on social media rather than appreciating. Or you can just give them a shout out for being an awesome person, for acknowledging your efforts and fixing the bugs but at the end of the day, it's all about making the internet a safe place. And then there's a very interesting talk on the internet. You can search for it by Cole Misadagi. She explains the hacker rights and how we can actually use these. You can actually, being a very responsible security researcher can uh, responsibly report these vulnerabilities or the vulnerabilities we actually discover in the application, the safe harbor thing, and blah blah stuff. So that's a pretty cool uh, talk. Just check it out in your leisure time. And then there's a plugin. If let's say you found a vulnerability on a website that you don't know have or had a security team or a product response team or a product security team. Yes, we Hack has a plugin. You can install it and you can use it for your own purposes. Just to get in touch with the security team. And I find mostly companies on these two platforms. So if you don't find any of them on through that plugin, you can find them on these two platforms, the very popular one. And then the engineering teams, like I said before, they were very kind enough to consider my request and look into it and reaching out to me. And I wasn't expecting anything like that. I was thinking like they would just fix the vulnerability and won't respond to that. But they were actually very kind enough to respond to my report, and yeah, recognizing it as well. And there is this open source disclosure program, this website called disclosure.io. Just check it out and you will get to know a lot of stuff. So, in my unfortunate demo stuff, I was using these tools, Frida, a very popular tool for dynamic instrumentation, objection on top of Frida, a burp suit. Everybody knows that, and I mean, everybody is in there, so they have everybody's experience, and I guess everybody knows about the burp suit, Genymotion thing. JDEX GUI for reverse engineering or decompiling the application from Somali to Java decompiler. So it's pretty helpful. APK tool is mainly used for building the application and decompiling the application. So at times you might face difficulties in decompiling the application through APK tool, but that's fine. There are times where you need to update the libraries for the APK tool. It's a very cool one. Let's say if you are not able to utilize the objection and you are not able to inject the libraries through objection, you can do that manually by using the APK tool, decompiling the whole APK, replacing the Somali code within the APK, and then recompiling it through it as well. And Python, again, very useful programming language I have seen till now for uh, assessing, or you can say dynamic assessment or for dynamic analysis of the application. So and it's important for us to just give it a try as well, and patience, that is always required. So with that, I would like to thank you, and everybody would I would consider everybody is staying safe, and yeah, hack the planet.